There are 4 memory management functions. So these are C functions. Each of them takes a set of input and gives you something. That's what a function is, right? So malloc is responsible for allocating a block of memory that contains the number of bytes specified in its parameters, right? So let's say if malloc 4, this means you're asking, right, your program to dynamically allocate, right? This is, let's say this is heap, 4 bytes of memory space. So this is 4 bytes, right? And then this malloc function then returns, right, a void pointer, right, to the first byte of the allocated memory. Okay, so there's very first byte right here. Malloc actually returns. Okay, malloc 4 returns that void pointers back to the caller, right? So that's what malloc is. The second memory allocation function, calloc here, this function is primarily used to allocate memory for arrays. It is different from malloc only in that this function calloc sets the memory to null characters. So let's say if we to do a calloc, something, let's say, so this calloc takes 2 parameters. One of them is the element count, and the second one is the element size, right? So the very first parameter is element count. Let's say if I want to allocate an array of 200 characters, right? There's 200 characters, then the second parameter would then be the size of what? Size, right, of chart, right? So this gives me the ability, right, at runtime to allocate essentially size of a chart is 1 byte. So there's 200 of them. So this is 200 bytes of memory space, right? Just like calloc, right? It returns the very first byte memory address back into the caller, right? So caller has a handle to the beginning address basically of this entire 200 bytes. Same thing with the malloc. Malloc returns the very first byte via that void pointer to the caller. The third function is called realloc, right? This is called reallocation. So this is a very inefficient function. So when we given a pointer to a previously, let's say, allocated block of memory, this realloc function changes the size of the block by deleting or sometimes extending the memory at the end of the block, right? So if the prior one is this, right? And you want to do a realloc, meaning you want to like expand the new array, right, to this much, then what you do is you said realloc, right? This is the prior one. I say this is P, right? That will be the first parameter. The second one would be the new size. So whatever the size is, let's say 200, right? And then it'll give you, 200 bytes in addition to what you have before. Like I said, this involves creating a new one and copying everything, right, that you have from the old one into the new one and deleting the old one. So realloc makes it really, really inefficient at runtime. This is not something that you would want to do often, but realloc is also part of the memory management that we frequently see in code. The last of which is what we call free. This is memory deallocation. So when memory locations allocated by malloc, calloc, or reallocs are no longer in use, meaning you're about to exit the program and you don't really need them, it will actually call free to deallocate them. So in C++, we call delete, right? C++ doesn't have free. Free is a C concept. So free is a function that is called in C to deallocate all of the previously allocated space. There is no auto memory management in C or C++. So you have to manually, right, call free on the allocated space, right? Otherwise, you get what's called memory leaks, which contributes to memory fragmentation. This is the source of lots of issues and some of the buggy softwares that basically leaks memory around